So this is a machine that I made that essentially opens up garlic. So here we've got some whole heads of garlic, and you simply put them in. And then the bottom, it drops out like this. So I'm gonna turn it off here. I'm trying to get it dialed in right now, and it seems pretty darn close to what I can achieve. You know, we've got some of the peel comes off, that's not a problem. Some, they're not all the way split, but that's pretty easy. Peel. I'd very much rather it be doing a little bit less than a little too much. If I adjust it to crack closer, then I can actually start damaging some of the cloves, which I really want to avoid at all costs. So at this point, I think that's about the capacity of what I've accomplished, and I don't think that I can really do much more than that. But the good news is that we're cracking, 500 pounds of garlic to plant this year. And the majority of the time, if you're doing 5 pounds, then just do it by hand. If you're doing even 50 pounds, just do it by hand. But once you're doing several hundred pounds, it takes a long time to crack the garlic. So, this one's damaged anyway. So, I find the majority of the time is just on starting it, on opening up the whole head in the beginning. Once you have it like this, or cracked in half like this one, it just is a second or two, if you have both hands, to separate that out. So I think this could, there's more refining could be done, but that's pretty good for me. As long as I'm not damaging any heads and I'm at least cracking them all in half. I don't love peeling it, but I don't think it really matters, to be honest. As long as the bottom isn't damaged. As long as no part of the thing is damaged. Anyway, so I'm going to basically call it on this project for now. And I'm going to use this because we still have some garlic to plant. So, just quickly, I'm going to walk you through what I did, what the design is. So, the bottom consists of a plate. This is actually a no-till coulter. So it's a flat coulter from an agricultural piece of machinery. And in fact, I'll just show you a new one so you can know what those look like. It doesn't really have to be something like this necessarily, but so I have some of these from farm use. Anyway, that's what the plate is. The whole structure, the box, sorry the focus is not doing very well this morning. This box is an attic exhaust fan. So normally there would be, this is the shaft. This thing would be horizontal. This is the motor back there, the belt shaft, and then this would just be where this opening was a normal fan. So it was an exhaust fan. So this was the shaft. This little funnel here is just to prevent garlic from falling down on this where it's rotating here, so ignore that. This is the shaft. So here is where the fan would have been. I cut the fan off, and I welded a collar onto that coulter, and then on the top of the coulter, I glued on a 1/2-inch piece of rubber. So you could use silicone or rubber. It's got to be pretty strong to withstand abrasion, but also flexible so that it won't hurt the garlic. And then the top, it looks a little bit complicated. It is a little bit complicated, but the idea is that you've got that flat plate on the bottom, and then the top here is a curved plate. And so this is the same thing, that rubber, and this is a disc, an agricultural disc. So you can see sort of flat on bottom, and then the disc curves. So what happens is that when the garlic goes in the middle, the rotation, when it's rotated really fast, throws it out to the side. And as it moves out to the side, it's going to encounter the top because it's moving moving out to the side, and the distance between that bottom plate and the disc is getting less as you make it to the edge. So then it gets squeezed basically. And just like that, it opens it up. So it squeezes the heads of garlic together between a flat disc that's rotating and a stationary disc that is curved. I epoxied in this piece of tire because the garlic comes out pretty fast. That way it hits this inside of the tire and falls down. And there's just a couple little extra pieces of tire so that things don't get sucked into the motor down there. The garlic falling on this has not caused any issues of yet. One little detail here is that attic exhaust fans, normally this whole rod assembly and bearings would be in the horizontal axis because it's a fan and it's not pushing up, it's pushing out. And this pulley and the rod here, basically, it's hard to explain, but if this is where the fan used to be, the rod was just sort of floating, if you know what I mean. There was no pressure on it this way or that way. Now, because of the garlic in here pressing between the roof and this plate, it's pushing this plate down. So there's a force this way. And to counter that, I put this bearing on the bottom to catch it, if that makes sense. Because otherwise, there would be a lot of friction right here, and that would have eventually, there's just a tiny little plastic washer that was there, because like I said, there isn't normally a force like downwards with how it was designed. So this way, I've made a space right there so that this isn't touching, because this is stationary and this is moving, as you can see. Let me just turn it on one more time. So that's the guy that's moving, and this is stationary. So I've made it so that there's actually a gap right there, and all the pressure is right down onto this bearing, and that's a greasable bearing. So now that can take as much force as the garlic will give. Now the other really big challenge was to be able to change the distance of the top and the bottom, the separation. So if you're cracking big garlic, you want to be able to raise this up. If you're cracking small garlic, you want to be able to lower it, but it needs to be pretty strong. So what I ended up doing was I built a wood frame off of the frame of our unit, and then I just used rods and clamps. So these are nice stainless rods because these have very low tolerances, so you need to use stainless there, or else there's probably a dozen other ways to do this, but I use rod and clamps. And to connect the rods to this plate was a pretty challenging, weird problem. I ended up finding this Packer, totally random piece of ag metal, and what I did was cut out room here for this rod. Cut out room there. And then I just built a jig where I had a 2x4 with holes drilled in it that far apart, 1, 2, so that they would be perfectly parallel so that it could raise up and down. And then I had a friend weld it in because this is cast and this is stainless, and he's good at doing crazy stuff like that. Anyway, so that's how I made the garlic cracker. Like I said, it does the first main part of the work, and then there's sorting to be done. And I do have some plans to add on a sort of screen on the bottom. It's not going to operate here. It's going to operate down somewhere else. And there's going to be a screen so that the garlic will fall through a screen. Small stuff will go through. And then ideally there would be a fan blowing to just winnow out the papers, and then essentially let all the good stuff fall to one spot. So anyway, that's a brief overview. I'll just maybe do a little bit more cracking just to give you an idea. Pretty wild. It's very fast. I'm curious to see how it performs when I actually load the whole thing all the way up with a continuous flow, but that may never happen. Who knows? So yeah, still looking pretty good. No damaged cloves as of yet. That one looks like it's damaged, but that's actually a split. That's a double head garlic anyway that it caught. There's one. There's a damaged clove. So, I don't exactly know how that happened. I think there's just some element of randomness where if it catches the edge at a certain angle. But the only other thing that I could do, well, if you have the distance set and you're doing one kind of garlic, one size of garlic, and then you do a larger one all of a sudden, that's when you run into problems. So I think I'm gonna have to pre-grade the garlic pretty effectively into different sizes and then run the machine according to those sizes. So anyway, that's what I've got so far, and I wonder if anyone else has done any similar projects. I'd love to see other solutions that people have come up with.